Good morning, everyone. It's great to have you here this morning, this very, very early morning on, I guess it's the second day of TechEd. So thank you so much for rolling out of bed after, I'm sure if you're like me, uno mas sangria last night. And so thanks a bunch for joining us. What we're going to talk about today is how we're bringing the Windows Azure website service into the private cloud as a part of the Windows Azure Pack. So this is what we announced yesterday. Brad Anderson announced it in our keynote, and we're actually very excited, to remind you that these bits are available as a technical preview and are downloadable as of yesterday, in fact. So, what is websites for Windows Server, or websites as a part of the Windows Azure Pack? We look at it really as a platform as a service for the modern web. We think about how we're taking the best parts of website hosting, which is a very well-defined, well-established market, and adding in the benefits of true platform-level services and really cloud optimizing what has been a very, traditionally well-known and established website hosting business. And when we think about what this means, we really think about two particular customers or two particular user personas. One is the developer. We want to provide them with a very powerful and self-service platform so they can quickly and easily provision, manage, and scale their web applications. The other group that we think about are IT professionals, and we want to provide them with a very flexible hosting solutions for the applications which they are responsible for managing. And one thing maybe we'll talk about a little bit more as we move further into our discussion today is when we look at how DevOps is changing the roles of the developer and the IT pro today, these things are kind of merging, and we'll talk about some of the features that we've built for DevOps scenarios, okay? We have three main pillars for websites for Windows Server. Number one is it's extremely important to us that the platform is scalable. So when you look at traditional web hosting, in many cases a web application is affinitized to a single server or a very small set of servers. And what we've done with websites for Windows Server and the Windows Azure Pack is we've taken these web applications and we've completely de-affinitized them from a single server in our website's cloud. And what this means is we can very, very easily and rapidly scale web applications. We can keep them up to date because we have multiple servers which can host the application at any given point in time, and we also allow you to deploy website clouds to multiple data centers, allowing you to support services out of multiple geographic areas. The next thing we think about is we want to ensure that because the web is, of course, publicly accessible in many cases, we want to make sure that we provide a secure solution for you. And we really boil this down into two main areas. Number one is we provide enterprise-grade availability with support for SSL certificates, custom domains, these sorts of things, and of course, Active Directory authentication for login and management of these resources. Then finally, we want to make it flexible. We want to provide you with hosting of web applications with your choice of languages, frameworks, and tools or development platforms, okay? And so really if we distill it, I'm from Kentucky in the United States. We make a lot of bourbon or whiskey there. So if I were to go for the 120 proof version, websites for Windows Server is a scalable, secure, and flexible platform for building powerful web applications to run your business, drive your brand, and to reach new customers. Now, my team in Microsoft, we have a very interesting and fascinating charter. We're responsible for the web workload on the server side of things, pretty much all up. And so we build things, as you can see here on the screen, from a single server or small number of server solution, IIS, as it ships in Windows Server, and as you guys are probably very familiar with and run in your data centers today. In addition, we scale from single server in our team all the way to cloud. And we look at the cloud in kind of two main areas. Public cloud, which we typically think of the clouds or data centers that Microsoft operates as a first-party service. And then we also have the private cloud or the hosted cloud, which is how you can take these Azure services and run them out of your data center. Maybe this is for government or regulatory compliance issues. So what we think about is how do we make the web platform, the Microsoft web platform, ubiquitously available from servers to cloud, regardless of where those servers or clouds exist or reside. Okay? So when we think about who we built this for, one thing that's interesting about the website's runtime, it is a modified version of IIS, or is a set of added services built on top of IIS, and it does target specific customer groups. First and foremost, we think of hosting service providers. So these would be providers such as 1&1, Host Europe, in the US, Rackspace or GoDaddy, okay? These are people that have to host a very, very large number of web applications and do it at extremely massive scale. The next group that we see that is highly interested in these types of services is the enterprises, where the IT department acts as an internal hosting internal hosting company, so that tenants or individuals inside of your organization can request websites or VMs or databases or service bus namespaces, queues. And so that's kind of the second group. And then finally, the third group is web ISVs that are transitioning to SaaS business models. Okay, any of you familiar with .NET Nuke or Umbraco? Okay, so both of those guys actually have parts of their businesses where they now provide SaaS offerings. And actually, both of those companies have built their SaaS offerings on top of websites for Windows Server in the Azure pack. Okay, so maybe to look at it from a different angle or from a different pivot, oftentimes we'll have people that say, well, I may or may not be one of those three customers at the top of the screen. So how do I know if this product is for me? If you have many websites running across many servers with many tenants, then this is probably a good solution for you to investigate deploying into your own data center. Okay? So when we look at the benefits of the platform as a whole, we think of 5 main areas or scenarios that we're able to deliver to you. Number one is it's ready for business. It's web scale and worldwide ready. We provide the best Visual Studio experience of any web hosting platform in the market today. We allow people to bring applications and services to market more quickly, and then we do this in a manner which is open and flexible. So when we say ready for business, what do we mean? Number one is we're enterprise grade. Out of the box, we provide great availability because, once again, our applications that are deployed to the website cloud are de-affinitized from any individual server. So in the event of a server failover, we're able to, in a matter of seconds, migrate that application to a new server so that you're able to maintain availability through hardware failure and these sorts of things. Okay? We also secure everything with SSL, and we'll demo here in a few minutes how your tenants can secure their individual sites with SSL certificates that they have procured and that they upload to the website cloud. We also think about how we're able to access other enterprise services. One of the benefits that we provide is because this is a web PaaS solution built by Microsoft, is we're built to work with technologies that you already have in your enterprise, such as Active Directory, these sorts of things, Service Bus, VMs, so on and so forth, SQL Server. Okay? So when we think about what it means to be web scale, first of all, we are load balanced out of the box. We talked about the availability benefits of this, but the other thing is this also makes it very, very easy for us to scale applications rapidly based on changes in workload or performance requirements which you may have. Number two, we're always up to date. So one of the fascinating things about this product, which I learned when I joined the team, actually joined this team about 2.5 years ago, and I've spent the last 2.5 years of my life bringing these Azure services to you guys. And we bring in over 140 different assets from both Microsoft and different participants in the open source community, things like MySQL, PHP, Node.js, and we pull the up-to-date versions of these various software packages, we validate them, test them, and then install them as an integrated part of the solution, okay? So there's no more, hey, am I using the right version of PHP? How do I modify my application host config? These sorts of things, none of that's required anymore. It's a turnkey solution, okay? We talked about the scale benefits. And then finally, it's a very highly economical solution. So because these applications are de-affinitized from servers, and because we allow applications to run in a single tenant or a multi-tenant execution environment, we allow you to host web applications inside of the website cloud in the most cost-efficient manner, or the most cost-efficient manner for you or your customers. We provide the best-in-class Visual Studio experience. So what does this mean? One, you can very easily move existing ASP.NET websites to the website service. Number two, you can deploy, build, and manage these websites from directly inside of Visual Studio. And we'll demo this here in just a few moments. And then finally, we provide great source control integration. So how many of you in the audience have used Git? Okay. Excellent. So the three of us, what we've done is we've integrated Git as a part of our hosting solution. And so what this means is your developers can very, very quickly publish applications directly from their source code repositories, and then roll the versions of their applications backwards and forwards as their needs required. And we'll demo that as well here in a few minutes. Okay? We think about how your customers can bring applications to market more quickly. Okay, one of the things that we see is the web moves fast. Okay, so how do we allow people to create websites in minutes? Allow them to do this with their favorite tools, because we see some people like Visual Studio, some people like Web Matrix, some people like Notepad++. Me, I use Cite or Scintilla. So there are a lot of different tools that people like to use, and we want to allow them to bring their own tools and then use their own deployment framework on top of that. So from a deployment perspective, we integrate with the top source control providers in market today. So we do GitHub, Bitbucket, Codeplex, and Dropbox. And then we also, of course, allow you to interact with a local or a remote Git repository. We support Web Deploy, which is employed, of course, by Visual Studio and Web Matrix. And then we also use FTP, which is probably the most widely used, but starting to grow a bit long in tooth publishing mechanism for websites today, okay? And then finally, we want to do this in an open and flexible manner. We allow people to choose the language that's best suited for the applications they're writing. So one of the things that we've seen emerge over the last 2, 3, 4 years are the emergence of what we sometimes call the polyglot programmer, or the multi-language programmer. And this is where developers often will say, hey, you know what? I want to choose the best language for the application that I'm building. So they might choose ASP.NET. They may be doing work in PHP. They may want to use Node.js. They may be doing natural language processing, and they want to use NLTK as a part of the Python suite or Python framework for building applications. And so we allow folks to do that. In addition, we also allow people to bring their own fast CGI handlers, upload those, and run them as a part of the website's cloud. So you can almost bring your own language and framework in many cases. Number two, we allow you to choose the database that you want. So we allow your applications to be backed by either MySQL or SQL Server databases. And I'll show you what this looks like here in a few moments. The next thing is we realize that many people don't always start with a blank page when they're building applications, right? Oftentimes they will use a pre-existing application and build and iterate on top of that. So perfect examples are .NET Nuke, Umbraco, Joomla, Drupal, WordPress. Many times web agencies will pull in these applications and will then customize them to meet the needs of their end users, right? And so what we do is we have an integrated web app gallery, which is curated by Microsoft to very quickly and easily allow people to deploy these apps into their website cloud. And then finally, and this is very important to me, there's zero lock-in with the platform. So because you can purchase these services from Microsoft and Windows Azure, because you can run them in your own data center, because you can find a hosting service provider that runs the Windows Azure pack, you have a large number of options as to where you can host these applications once they are built. Cool? So we think that people will end up using this in 4 primary scenarios. Number one is global web presence. So if I am a large company and I need to host my website in a way that's accessible around the world, we want to provide a secure, scalable, and reliable way for doing that. Okay, we provide an easy-to-use self-service portal. We allow people to move websites quickly and easily. And of course, we allow people to also very quickly connect their web applications to services that exist in Windows Azure, to services that are included in the Windows Azure pack. And of course, once again, these services can reside in any of the 3 clouds. Okay? And then we allow people to very quickly and easily deploy and scale that web presence. So the other thing that we see is the cloud lends itself very well to digital marketing campaigns. So maybe I'm wanting to run a specific campaign to engage with customers. We allow people to very quickly and easily do that on the website's paths. We allow people to design, develop, and deliver experiences that reach the customers with rich and interactive media. So because we support all the latest languages and frameworks, you can build awesome applications on top of the platform. And then, as we spoke about earlier, we allow people to start from scratch, or we allow people to build on top of pre-existing templates. And then, of course, to reiterate, it's very, very easy and very, very fast to scale applications once they've been deployed to the website's cloud. We also think that people will use websites for line of business applications where they're able to harness the power of our developer stack to build enterprise-ready modern business applications. When we think about what this involves, we think about people using Active Directory or Azure Active Directory to federate identity. Sometimes this will mean integration with Org ID inside of Office 365. We think about how people are able to connect these different resources that maybe exist in your own data center, maybe they exist in the public cloud, maybe they exist in a service provider cloud. And then the other thing that we think about is people that are building custom applications that snap into Office 365 and SharePoint. You know, inside of O365 or inside of SharePoint, you're somewhat limited in the application development that you can do there. Well, with the website's runtime, you're very easily able to build apps which are hosted by websites, but visually to your user appear to be an integrated solution with SharePoint. And then I'm going to skip that slide. So, ready for demos, guys? I know that was a long lap of PowerPoint, but hey, you know, if we don't go through the slides, the marketing team gets very, very upset with me and sends me nasty letters after the end of the presentation. So, excellent. What I'm going to do is I'm going to pull up the self-service portal. And this is where you'll notice it actually looks an awful lot like the Azure portal. That's because it's built on the exact same code, okay? The services, I'm signed in as a service consumer or a tenant, and the services that are assigned to the plan, which I have subscribed to, are lit up there on the left-hand side of my screen, okay? And so from this interface, I can very, very quickly and easily create websites, virtual machines, databases, and service bus namespaces or queues. Of course, I did not subscribe to the gold plan, and so I do not have access to create service bus stuff today. But, you know, so first thing I want to show is our zero code deployment from Gallery experience. So what I'm going to do is I'm going to say create a new site from Gallery, and what happens is we pull in from various third parties the most popular open source web applications. Okay, .NET Nuke, Umbraco, Joomla, Drupal, WordPress, so on and so forth. In addition, we bring in a lot of templates that people can use to start building applications from scratch. So things like an ASP.NET empty site or a Django site or these sorts of things, okay? So to demo this experience, since we all know and love WordPress, we'll demo WordPress this morning, okay? And so I'm going to be prompted for providing an application site URL. So we'll call this TechEd Press. And what you'll notice is here I have a drop down. And what we do is we actually inspect the manifests that were provided by Automatic and WordPress to determine that this web application actually needs a MySQL database to function properly, okay? And so we allow you to create a new database or tie this website to an existing MySQL database. In this case, you can see I don't have a database created. And so I'm going to click Next. I'm going to provide a database name. I'm going to provide a database user. I'm going to type my super secure password the same way twice with any luck. And then I'm going to click OK. And so what's going to happen in the background here, and it'll probably happen more quickly than I can explain it, is we pull a web deploy package, which has been created by WordPress.org or Automatic. We pull that web deploy package across the wire. We then unarchive it, and we see that we have a set of PHP files that we need to drop on the web farm, and we see that we have a database and a set of DML and DDL scripts that we need to run against the MySQL server, and we see that there's a set of transforms that we need to apply to the website to point the website at the database that we just provisioned, okay? And so I'm going to click. You'll see it happened more quickly than I can explain it. I don't know if that speaks to the power of the platform or my poor speaking skills, but you'll see it provisioned the website very quickly. And so here in a few moments, you'll see I'm presented with the first time WordPress installation experience, TechEd Press. I will provide a super secure password, and hopefully I can type it the same way twice. I will complete the installation process. That will take a few moments. And I can go back here and browse to my site, and you'll see my site's up and running in just a couple seconds. So very, very fast, very, very easy, okay? So think about all the times that someone has called you up in your IT department and say, hey, I want a website, and you have to go through the process of provision app pools, sometimes provisioning servers and going through all these things. We were able to delegate that to our tenants and allow them to do it all by themselves with no coding required. They did have to be able to type in the same password twice, right? So you know, if you're familiar with the hosting service provider space, this capability by itself, it's great for us to have it as a part of our platform, but let's face it, like Plesk has been able to deploy WordPress for a very, very long time. So what's unique or different about what we're doing here? Well, the first thing is, if I go to my site dashboard, you'll see, and it hasn't filled in yet, but what we do is we track real-time usage data. So how much CPU time, how much bandwidth, inbound and outbound, how many requests, how many server errors, how much storage, how much memory my application is using, okay? And we surface that to tenants in the portal. And so one of the things that we commonly see is people will see a performance issue in their application and they'll wonder why things are broken or why things more commonly are just running slowly. Okay? Through this interface, we allow people to very, very quickly and easily see what's going on with their application so that they can then take action upon it. Okay? And so let's say that I'm seeing, we're going to hypothetically assume I have usage data here that indicates that my website is running hot and I need to scale my website, okay? Let's say I'm seeing increased load. What I'm going to do is I'm going to go to my Scale tab. And what you'll see is I have the option of creating websites in shared mode or reserved mode. Share mode is where my website is deployed to a multi-tenant environment where many, many websites execute and run on the same server. Reserved mode is where my applications or my websites are given their own server so that I have improved isolation from noisy neighbor, improved security, these sorts of things, okay? And you'll see that my website, it just so happens to already be configured in the reserved mode. Okay? Now, in addition to being able to select your tenancy model, we also allow people to select how large they would like these reserved or single tenant instances to be. So I can say I would like that instance to be a small, a medium, or a large. And these are logical groupings so that you can define what a small reserved instance is for your customers. So that could be a machine with 1 core, 1 gig of RAM. It could be a machine with 4 cores and 8 gigs of RAM. It's really up to you. So you could just treat these things as logical groups, okay? And then in addition to allowing people to move from multi-tenant to single-tenant modes and allowing people to scale vertically, we also allow people to scale horizontally. So I can define, do I want my web applications to run across 1, 2, or 3 reserved instances, okay? So we provide a great way for people to scale not only horizontally, but vertically as well, okay? So we've covered no-code application deployment from Gallery. We've covered how we provision MySQL databases without any sort of user intervention as an integrated part of the experience. And we've talked about how you can see usage metrics and make scaling decisions based on those scaling metrics. Okay, so the next thing I want to do is show you what our Visual Studio integration looks like. And so what I'm going to do is I'm going to create a new website, and I'm going to just do a quick create. So we'll call this TechEd VS. Okay, and I'm going to create that website. It's going to prompt me and say, hey, you made changes. I don't care. I don't need to scale my website. I'm assuming you guys aren't going to all try to load my WordPress site at the exact same time. So my TechEd Visual Studio site is created now. And so what you'll see right here is I have a link which allows me to download a publishing profile, okay? And this publishing profile is an XML document which contains all the information that Visual Studio needs to publish applications to my private instantiation of the website service. So I'm going to save that. And now I'm going to go into Visual Studio. Visual Studio is going to launch, and I believe I'm using the eval edition, so it's going to ask me for a licensing key as well. And so with VS up and running, I'll go to New, and I'll do new website. And one thing that's important to keep in mind here is I didn't do like new web role or new cloud service or anything like that. I did new website, okay? It's very, very important to us that people are able to deploy apps as they're accustomed to doing them, as opposed to learning how to build apps in a new way, okay? And so let's see, we will create an empty website. I will call the website TechEd VS. And I'll click OK. And so what's going to happen here in the background is Visual Studio is going to begin creating this project. Okay, here in a moment we'll see my solution is ready to go in the Solution Explorer. So I'm going to right click, I'll add a new item. We'll just make it a web form, default ASPX. We'll just add some simple text here. So how about Windows, Azure, Pack, and Visual Studio Rock? So I'll save that. And then what I can do is I can go over here to my project and I can click Publish Website. Okay, and what it's going to do is it's going to prompt me to select or import a publishing profile. This was that file I downloaded a few moments ago. Okay, I'll import that. I will browse, and I will select today's publish settings file. I'll click OK, and I'll click Publish. I'll be prompted with a certificate error here in a moment. Oh, or not. And you'll see that my application was deployed directly from within Visual Studio in a matter of just a few seconds. Okay, so very, very tight integration between the developer tooling that you use on a day-to-day basis and the Windows Azure Pack. Okay, so next demo on our list is let's do some source control stuff. This is my favorite because I actually come from the hosting industry and used to spend a lot of time working on the command line and scripting, and this is a demo I get to do pretty much completely from the command line. So this is one of my favorites. So I'm going to create a new website, and I'll do a quick create, and we'll call this TechEd Git. So we'll create that website. Took, once again, just a split second to do so, and I'm going to select it. And then you'll see here we have a link for integrating source control. And we provide people with a number of options. So you can integrate or link to a local Git repository, GitHub, Dropbox, Bitbucket, Codeplex, or a random other external Git repository, okay? And for this demo, we'll just do a local Git repository, okay? And so while it creates my Git repository, I'm going to pull up my command prompt. And let's whip up a directory real fast, make dir TechEd EU. Go into that directory, and the first thing I'm going to do is I'm going to initialize my Git repository. This looks familiar to the Git users in the room. You'll notice nothing fancy we're doing here. It's just regular old Git from the command prompt. Next thing I'll do is I'll fire up Notepad, and we talked about using different stacks earlier, so how about we'll do PHP, okay? So write a little hello world. And I'm going to save that. I'm going to go back to Notepad. I am going to add all files to my repository. I'm going to commit with a super helpful comment, hello world. And you'll see that it has now committed that to my local repository. So the next thing that I need to do is inform my local repository about the remote repository that exists inside of the Windows Azure Pack. And these commands, I can never remember them, and so fortunately our UI guys were brilliant enough to put the commands I need to run right here. And I need to make a quick little edit to this. Just for the sake of keeping the demos running smoothly. So I'm going to add my remote repository, and then I'm going to git push websites master. It's going to prompt me for my publishing password. And so now what's going to happen is the Git tooling is going to look at the differences or the deltas between my local repository and what exists inside of the Websites Cloud and Windows Azure Pack. Okay? In this case, it's going to realize it needs to push the entire repository, and so it makes those decisions, and you'll see that in the background, it's actually asynchronously updated the UI to reflect that I have a new deployment up and running, okay? And you'll see we actually even show the deployment comments, and we show that I made those changes, and we deployed using this publishing user, okay? So I will now browse, and we'll see that Hello World is up and running, okay? Now let's say that we wanted to make a change to this website, okay? And I'm just going to go back into Notepad again. And you know what? I know that this never happens, but let's make a syntax error, okay? We'll just make it break. So we'll save that, okay? And then I'll add all changes. I will git commit. I meant to do that, right? Because we all mean to do those syntax errors. And then I'm going to push those changes to my website. Okay? I'm going to enter my publishing password. Once again, it's going to look at the deltas, and it's then going to push those things, those changes live. And of course, you'll see that our snazzy UI in the background also informs the user through the self-service portal that the new application has been pushed live. But of course, you know, I click browse, and nothing's going to happen. It's not going to work, right? Because I broke the site. So the cool thing is I can go right back to my UI, select the old version of the app, hit redeploy. It's going to ask me if I really want to do that in true Microsoft UI style. And then it's going to redeploy the initial version of the application. Okay? And so if I go back to this page here where we had our 500 internal server error earlier, I can refresh and I'm back to the original working version of my application. So pretty cool way to very iteratively and quickly move forward with full source control integration and then also roll back when things go wrong, because we all know they do. Okay? So that is our first batch of demos for the day. What I'm going to do now is we're going to talk a little bit about the new feature. The cool thing is everything I showed here was actually in the V1 version of the product, which we released last January. Okay, so the cool thing is all those features actually have a lot of bake time at this point. They're pretty well proven at this point. So what I'd like to do now is talk about the new features that we introduced with the technical preview that became available yesterday. Okay, sound good? And can you guys still hear me okay? I apologize. My voice is a little weak today, so we're good? Okay, excellent. So let me go back over to here and hit my clicker. So maybe before we go into vNext features, I should actually explain where these websites are running. Okay? So the UI that I've been clicking around in is what we call the Service Management Portal. And I've been using the tenant portal, or the portal that your service consumers will be using. Okay? This tenant portal is an HTML5, JavaScript, CSS-based web application over the top of MVC server side. And that application mainly just communicates, or exclusively communicates, with our Service Management API. Okay? The Service Management API is the on-premises variant of RDFE that we run in Azure. And so the cool thing is, we're actually striving for API consistency between what we run in the Windows Azure pack and what you have in Windows Azure. And so, as you'll see, we release like the PowerShell SDKs for provisioning websites, VMs, these sorts of things. Those same PowerShell scripts, those same REST APIs that you use in Azure, you'll also be able to use those against your private Azure pack deployment, or Azure pack as it's deployed in your local hosting service provider. Okay? So that Service Management API, these things are actually, all those gray items there on the left are shared by all of the services that are in the Windows Azure pack. So as soon as we get to this green box on over to the right, those are actually roles which are exclusive to the website service. Okay? So the Service Management API then communicates with our management servers. These are our REST APIs that are specific to the that was our code name. By the way, in case you've ever heard code name Antares, that's actually what websites is, okay? So I'm sure I will slip up again. We aren't supposed to use code names when we do this, but after 2.5 years of working on a code name project, it's hard to break the old habits, right? So management server handles REST operations such as create website, or tell me how much bandwidth or memory or CPU I have used. It stops and starts my website. It actually gives me that publish settings file, right? And so everything that we did through Service Management Portal is talking to Service Management API and our management servers. Okay? Those management servers then communicate with our controllers to make changes to a runtime database. And so one of the things that's extremely unique about websites is how many of you today run website farms with more than, let's say, 10 websites on them? Okay? How many of you run more than 100 websites in a web farm? Okay? How many do more than 1,000? On a web farm? You are a brave individual, sir, because what you will find, I'm sure, is as you have more and more web applications on the server, the application config file grows to such a large size that we have difficulty parsing the XML in a performant manner. Or you'll find that making config changes can be a bit challenging as well. Typically, we find that happens at around 2,500 to 3,000 sites on a single box, okay? And so what we do with the website service is we take that config file and we shred it, and we store it inside of a SQL Server database. And so what that allows us to do is to store literally millions of config files in a very, very performant manner, okay? So all of my application configuration, all of my scale information is persisted to that runtime database, okay? And so when a request actually comes in, someone tries to access the website for the very first time, what happens is that request hits our front ends at the top of the screen, okay? These front ends run application request routing and use URL rewrite to determine where they should route these requests, okay? These decisions are based on a number of criteria. Number one is this website running in shared mode or reserved mode? And if they're running in reserved mode, how many servers do I need to bring into the farm for this specific set of websites, okay? Do I need to If web workers have failed in the farm, do I need to route requests to a new worker that maybe previously hasn't been servicing these websites, so on and so forth, okay? And of course, those front ends are querying that information directly from our runtime database, okay? That runtime database, by the way, is running on SQL Server, okay? So then the request makes it down to the web worker. And the web worker is pretty much what you would think of as being a regular web server in a typical web farm. But of course, we've pre-deployed and pre-configured all of the various application stacks that the developers want to use in these farms, okay? The other thing that's interesting is IIS folks out there, you're familiar with the Windows Process Activation Service, yeah? Well, we actually use a modified version of this called DWAS, or Dynamic Windows Process Activation Service. Okay, and what this allows us to do is dynamically bind and unbind sites on the individual web worker, hydrating the configurations from the runtime database. Okay, and this is how we're able to run single web farms in Windows Azure that support tens of thousands of websites. Okay, so covered web worker. All of these web workers sit over the top of file servers, or in many cases what we see is being like a file server cluster, okay? And we use shared content, as you're probably familiar with using, with IIS. And that's why when we publish an application, you're able to scale it so quickly, is because the content resides on the file server, the configuration resides in the runtime database. And so all of the web workers in the farm are able to access the configuration and the content at any given point in time. Make sense? Cool. And then at the very, very bottom of the screen, we have our publisher. This is where we expose our FTP and our web deploy endpoints for publishing activity. Okay? Trying to think if there's anything else we should cover while we're on this slide. I personally love this slide. I could talk about it for like 4 hours. I'm sure you don't want to hear me ramble on about the architecture for 4 hours. So only other thing that you might be interested in is our controllers do run a modified version of Web Farm Framework. That's how we're able to perform health monitoring inside of the website's cloud to determine whether or not a web worker or a publisher or a front end has become unhealthy. It's also how, when you're deploying the website's cloud, you're able to give us a server name, and that server that you've given us, we turn it into a front end or a web worker or a publisher. So it's much, much easier than, we talked about those 140 assets that we pull in to compose the website's cloud. Imagine trying to deploy all that manually. It would be practically impossible, okay? And so we use WFF running on the controller to very quickly and easily configure any of the roles in the website's cloud. So I know we've talked a lot about architecture, and I know I've been talking lots. So I want to pause. Are there any questions that you have? Yes, sir. What is stored in the run? So the runtime database is where we store performance information about the farm, because we have to determine, hey, is a web worker like too heavily loaded? It's where we store all of the configurations for all of the web apps that run in the farm, okay? So we have a bunch of little application host configs, actually, that exist inside of that database. Okay, it also contains the configuration of the website, for example, the scale that you've defined as well, so that the front ends know how to route the requests. We also track, because we're allowing users to select whether they want to operate in a single tenant or a multi-tenant mode. We're tracking which of those web workers are shared web workers and which one of those web workers are reserved instances and which ones are small, medium, and large. Does that make sense? And did I answer your question? Okay, excellent. Yes, sir.
I have a question about how do you recommend to bundle those various roles to physical computers, because several roles can run on a single computer, and what would you recommend how to distribute it over the physical hardware?
So that's an excellent question. And to repeat the question is effectively, with these roles, how do we recommend deploying that to physical hardware? So the first thing to keep in mind, and this is very important, it's in the documentation, but it's something that many people easily gloss over, is these roles were built for running at scale in Azure. Okay? And so what that means is I cannot install a front end on the same virtual machine or OS environment as, for example, a web worker. It won't work, and what will happen is we'll keep trying to auto repair the machine, and it'll look like the machine's just stuck in a reboot cycle. Okay? So don't try that. However, we actually do all of our development on top of Hyper-V virtual machines. So we have a lot of experience running this in virtualized environments. In fact, almost all of our customers that have deployed the solution to date have been deploying into virtualized environments. Okay? So to dig into your question a little bit more as far as how we recommend picking which VMs go to which physical hosts, we really think of it in terms of availability groups, right? And so if I have two front ends, like I have in the diagram, I'm probably going to want to put front end 1 on physical host A and front end 2 on physical host B. Okay? So you can almost like draw a line directly down the middle of the various tiers. Does that make sense? So that way if you had a physical server failure, you're able to continue to maintain availability because you have another one of those role instance types available. Now, with that said, of course, our file servers there, we're assuming in the case of this diagram that that's actually a file server cluster. So that's a little different where you can't just draw the line down the middle of the slide. Does that make sense?
Maybe I should ask a little differently. I would like to ask if it's a good idea to put service management portal and service management up into single hosts, regardless of if it's virtual or physical, or bundle management server in. Let's say that I would have thousands of websites. So I would need appropriate number of web workers. They are out of question.
Yeah.
But I would have 1,000 customers. It's a good idea to bundle enter the left part from runtime DB to the left to single machine, or every role is to be on a single channel, whatever.
So I guess the way I think of it is service management portal and API many times can be co-located on the same machine without negative performance impacts. Typically, people will choose not to co-locate them, mainly because of security concerns and wanting isolation between what your tenants are using and the APIs. Okay, but maybe to clarify my line drawing question. You're drawing a horizontal line over to this point, and then you're drawing a vertical line here. Does that make sense? And if we need to talk more about topology, that'd probably be good for us to chat about after the session. Okay? Okay? Yes, sir. So the question was one subscription per... So the implementations, I'm going to try to answer your question in context to give everyone else understanding. The way we manage subscriptions and plans and quotas is different in the private cloud than we do in Azure, because Azure's built on top of a utility billing model, and we realize that enterprises a lot of times have a service catalog or a chargeback model, which may not align to how we run things in the Windows Azure pack. Okay, and so what we allow you to do through your plan authoring experience is when you define a plan, you can select which website cloud or which service bus cloud or which database cloud or which VM cloud is associated with that plan. Okay? And then individual users can sign up for multiple plans. So hypothetically, I could have my Europe website hosting plan, I could have my North America website hosting plan, and I can have my APAC hosting plan. Okay? Now that is done through separate plans or subscriptions, but it is able to be managed all from the same user interface for the tenant. Did I answer your question? Understood, understood. And I don't have that as a part of my regular demo routine, but maybe afterwards I can show you one-on-one and we can go through that. Okay, cool. Any other questions? You've been holding your hand up the longest, I think. Yes, sir.
Do you need to run this Azure pack? Do you need some SQL servers or system center?
That's nice. That's what my question too.
Okay. So the question is, what are kind of the hardware and software requirements for running the Windows Azure pack? And not to be a consultant, but the answer is it depends. So with that in mind, the reason I say it depends is it depends on which of the services you want to deploy to your data center and at what scale you want to deploy those services, okay? So for example, if you're wanting to do VMs, that requires Hyper-V, it requires System Center, and of course it requires a sufficient number of virtualization hosts to support the VMs that you want to deploy. It also uses a service provider foundation. Yes, sir. Virtual Machine Manager and Orchestrator, actually. Okay. But then, of course, that brings in a kind of System Center brings in its own set of dependencies, right? So you're probably going to have a need for Active Directory. You're going to have a need for some SQL servers, so on and so forth. Okay. I can tell you from a hardware or a minimum requirements perspective, if you deploy Service Management Portal and Service Management API to the same machine, this is called the Express install in the web platform installer. That requires a virtual machine with 8 gigabytes of memory. It's fairly low disk footprint and moderate CPU footprint. And we realize that everyone oversubscribes CPU when they virtualize anyway, so we really don't bother with making CPU recommendations. Okay, for management server, controller, front-end, web worker, file server, and publisher, you have to have one of each of those roles, and we recommend that each of those roles have at least 4 gigabytes of memory. Okay, so look at it as, to get started, 6 virtual machines, 4 gigabytes of memory each for the website service. The service bus service can be deployed on a single VM. So it has a very compact footprint to start with, but then there's also, for availability, like a 3-node option as well, and then it scales from there. Okay, so I hope I was able to give you more than just the vague "it depends" answer, but it does really depend on which services you want to deploy and at what scale you want to deploy them. Because, like, for example, that 6 VM example I gave you is like the getting started configuration for the website service. We have hosting service providers that want to run 25,000, 30,000 websites on a single website cloud, similar to what we do in Windows Azure. You aren't going to run 25,000 sites on 6 VMs. So, at the end of the day, we don't do any magic when it comes to the memory that's consumed by hosting websites or the memory and CPU that's required for VMs or these sorts of things. We really do a lot more in terms of orchestration and those sorts of things, okay? And if you have more questions about that, it does cover minimum hardware requirements in the installation documentation, and so that's probably the best source for that information there. So did I answer your question? Excellent. Cool. Any other questions? And I'll take one more, and then we'll go back to V2, new features, and more demos, okay? Yes, sir. Excellent question. The question was, can those file servers be replaced by a scale-out file server cluster? Today, we do not recommend that, and the reason why is if you look at how the ASP.NET Change Notification System works, which is integral to how IIS behaves, it does a large number of metadata reads and writes. And when you look at how scale-out file servers behave, they end up redirecting metadata reads and writes, and so you end up in a peculiar state where you end up redirecting a large amount of I/O instead of just sending it to where you want to go. So today we recommend for websites deployment primarily vertical scaling of file servers, but fortunately, file servers have been around for a long time and they scale vertically pretty well. So you put a large number of spindles, attach it to your file server cluster, you provide, a nice fat pipe, 10 gig or something like that in and out of your file server. You're going to be in pretty good shape from a scale perspective if you're talking about a large number of websites. Does that make sense, and did I answer your question? Okay. Yeah. So, I mean, we do not recommend scale-out file server clusters for the file server roles. It is something that we are thinking about how to better address in future versions of the product. Okay? Okay. Cool. So, preview was announced yesterday. You can download it today. That's just all that really says. And of course, we will RTM or GA later this year. So I'm sure what you actually, kind of want to see and learn more about now is what are the new things that we've done inside of our vNext. The first thing is a feature that we call dynamic site hibernation. And the scenario that we looked at here is how do we balance site density and performance, because people are typically trying to run a large number of web applications on a single server, but at the end of the day, these applications do have a memory footprint, and like we were talking about earlier, we're limited and we can't really do a whole lot of magic with how memory gets allocated in Windows Server, right? It is what it is. And so what we looked at doing was, you guys are familiar with setting idle timeout in IIS? And as soon as your website times out and the process is spun down and someone comes in and accesses the site, it's really slow that first time, right? It'll typically perform well after that. And we really wanted to we call that the cold start problem, and we wanted to fix that for you. Okay, and that wastes a lot of resources when you have the apps up and running, but then you have a large startup time when the app is cold. And so what we started doing, and this is a feature that's available in the R2 version of the Azure Pack and in the R2 version of Windows. It's actually built into Core IIS as well, in case you don't want to use Azure Pack. We page out the worker process when we reach that timeout period instead of terminating it. And so if you back your page file with like an SSD or something like that, you see lightning fast responses, okay? Because we aren't spinning up a cold site, and we're able to page back in very quickly. So this has two real benefits when we look at how it behaves in production. Number one is, in many cases, you're able to host a larger number of websites on a single machine. The other thing is, because you don't encounter the cold start problem as frequently. I wouldn't say you never encounter it, you just don't encounter it as frequently because memory pressure is lower on the box. You see performance benefits or improvements as well, okay? And if you want to know what it looks like, there's actually a session going on right now. Normally we tell people, oh, go check out the other session because they have a really cool demo where they muck around with this, but they scheduled it at the same time as this. So stream the session, maybe after you're done here, and Wade does an excellent demo of how this feature behaves. But it's pretty cool, and we think is dramatically going to change the economics of running website clouds. Okay. The next thing that we think about is how to enable more modern web applications, right? We see how people are building new apps that are connected to mobile devices and these sorts of things, right? And the challenge is that the web, generally speaking, was built to pull, right? You have a client that connects to a server and it sends it requests some information and it pulls that back, right? But the difference is when we look at these more interactive apps and the more modern apps, people are wanting to move to more of a push model where the server has a way to push information to the client. And so what is our solution for this? Well, what we've done is by implementing the WebSocket protocol, we enable bidirectional communication over HTTP and HTTPS. And so to show you what this looks like, I'm going to switch over to my demo environment. Security first. Give me just a moment while we reload our portal. And so what you'll see here in just a moment is I have an application. It's called WebSocket. And do any of you read the Dan Brown books? So he had the new Inferno book, so I decided to build an application that reads back Dante over a WebSockets connection, okay? And so I'm going to go to my WebSockets app. I'm going to click Browse. And so what you're going to see is, as I talk, the server is actually asynchronously pushing through a persistent connection lines from Dante to my client. Okay? And so when we think of the types of applications that can use this, think of like social interaction applications like chat, right? It's very, very inefficient to use long polling for chat type application. This allows there to be a persistent connection between the client and server, and the server pushes messages to the client, right? We also think about news or stock ticker type information. So all sorts of interesting new application models that are allowed through this technology. The other thing is we realize that building these type of apps can potentially increase the amount of load that's on your servers. And so this, as a feature, can be enabled or disabled through our plan authoring experience, which I'll demo here in a few moments, okay? So, next V2 feature. 64-bit processes or worker processes. So one of the things that we're thinking about more and more is how do we make the cloud enterprise ready, okay? And when we look at a lot of enterprise web applications, many of them are built to run in 64-bit worker processes. The web hosting industry in general, in many cases, still likes to do 32-bit hosting for a number of reasons. And so we're trying to, enterpriseify, if you will. I think I just made up a word. But make web hosting more enterprise ready, okay? And the challenge is that these enterprise apps, they need 64-bit because they have large memory footprints above the 3.6 gigs that's available, through 32-bit address space. And so our solution here is we enable 64-bit worker processes. And to show you what that looks like, over here, I'm going to go back to my tenant portal, and I have an application called 64-bit, and it's very, very simple. When I browse to my app, it's going to say, am I 64-bit? And then we echo the bitness of the worker process itself. Okay, and it says false. So this right now is not a 64-bit worker process. And once again, this is how many hosting service providers actually do things today. 32-bit is kind of the de facto standard. In fact, good luck even finding a 64-bit version of PHP. PHP is pretty much 32-bit exclusively. So what I'm going to do is I'm going to go back to my portal here. I am going to go to my configure tab, and this is where we allow tenants to override various configuration options on their website. So it's where I can enable or disable WebSockets on my site, and where I can select 64-bit or 32-bit bitness or platform. So I'm going to switch this app to 64-bit. I'm going to save, and it's going to make that configuration change to my app. I'm going to go back over to here. I'm going to refresh the page, and you'll see am I 64-bit is now true. So I was able to move from a 32-bit worker process to a 64-bit worker process with just, 2 or 3 clicks. Now, we realize that because the web space is traditionally 32-bit, that you may not necessarily want to allow all of your customers to do this. And so similar to how we allow you to define WebSockets behavior for your tenants through plan authoring, we also allow you to allow or deny this configuration change based on the plans that you author. Okay? So that's 64-bit. The next thing is IPv6. We all realize that we're running out of IPv4 addresses, right? This is becoming a huge, huge issue around the world. And the challenge was we really just ran out of time when we were building V1. We realized that people needed it, but we just, like I said, we didn't have time to build it in the product. So it's there in V2, and really our solution, it wasn't really complicated. We just had to do the work, right? And so to show you what that looks like, I have a website that I've created, and it's not fancy. I know I'm not going to win any coding awards for the websites that I'm showing you guys today, but I have this IPv6 website right now. And I'm going to click Browse, and you're going to see we get our new site created page, and you're going to say, well, wait a second, that was very boring. And that's kind of the beauty of a proper IPv6 implementation, is you don't know it's there in many cases, okay? And so what I'm going to do to, maybe show you that it is in fact running over IPv6 is I'm going to pull up Chrome, and I have a great little plugin over here which tells me whether or not I'm accessing the site via IPv4 or IPv6. And you'll see over here I get a little green icon, and I'm not sure if that's legible on the screen or not, but you'll see that my local machine is IPv4, but I'm connecting to an IPv6 address, which just so happens to reside at SoftLayer, one of our hosting service providers in the United States. So my website is accessible via IPv6. Interestingly enough, I have, because there's a 4A record for that address that I access, if I go to my IPv4 DNS entry, which does not have a 4A record, you'll see that this is accessible via v4 only, right? So IPv6 support built in out of the box, and once again, the beauty of it is it's completely transparent to the user, okay? The next thing is we talked a little bit about plan and add-on authoring. We realized that enterprises have service catalogs. Hosting service providers like to build packages that they sell to their customers. And we wanted to allow you to build these sorts of offers or these entries in the service catalog for your users, okay? And so the challenge is, how do we balance bundling or package type or service catalog type sales with more a la carte purchasing options? Like when you look at how Azure's business is run, it's very a la carte, right? You pick individual items and then you get billed on a utility basis. And so our solution was to provide base plans, which is a package of services, where you can then add additional add-ons or upsell type entities to that, okay? And so to show you what that looks like, I'm going to, for the first time today, I'm going to pull up the admin portal, okay? So I have that over here in my other browser, and I'm going to need to log in again. And so what I'm going to do once this loads is I'm going to go down to our plan authoring selection, and I'm going to create a new plan. So I'm going to go new, plan, and then create plan. Okay, and we'll call this TechEd EU plan. I'm going to click next. And so the next thing that happens is I'm able to define which services are included in this plan. Okay, so websites, VMs, databases, or service bus. Okay. And the other thing that's interesting is that I'm able to select, in case I have multiple clouds in my environment for these different services, I can select which cloud is included in this plan. So once again, we were talking about earlier, if I have the Europe cloud or the APAC cloud or the North America cloud, I would be able to select those items here. Okay? So what I'm going to do is I'm going to select website cloud. I'm going to hit OK. And so what's going to happen now is it's going to create this metadata around what resources can be consumed by the website cloud. You'll see we track how many signups for this plan occur each day and what the total number of signups are for that plan. Okay? So I'm going to scroll down here and select the actual plan services. And so what this UI allows me to do is actually specify which services and how much of these various services my tenants can consume. So I can define how much CPU time, memory, bandwidth, storage, number of instances, sites. I can also define what features they can use. So you'll see I can determine whether or not a user can use a custom domain or use WebSockets, or whether or not we allow them to flip back and forth between 32 and 64-bit. We allow you to define, what SSL options are available to them. These sorts of things, right? So it's all there. And the interesting thing is this allows you to build some very, very unique offers. So one of the things that we often see is that hosting service providers or, even enterprise IT, if you're wanting to manage how people are using SSL in your environment, a lot of times you may not want anyone to be able to use SSL unless they are paying more for it or unless you've specifically approved it. Okay, and so I can go in here and disable SSL across my single tenant and multi-tenant execution models. Okay, Once that's done, I'm going to save. I can then go in and I can create an add-on that is my SSL add-on. So we'll call this TechEd EU add-on. I'm going to go to next. I'll select Website Cloud. I'll click OK. It's going to create that add-on. And then I can go in here and I can say, for example, you'll see all the quotas are 0 because the add-ons are additive relative to what's in the base plan. And then I can go in and say, hey, you know what? SSL support, if someone purchases this add-on, I can go and say, hey, give them SNI-based SSL and IPv4-based SSL. And by the way, we do SNI-based SSL, which is shared IP with the host header outside of the TLS negotiation. We do regular IPv4-based SSL, and we do IPv6-based SSL. And so I'm going to save those changes here, and then I'm going to go back to my TechEd base plan that I created a few moments ago. And then I can link an add-on to it. You'll see I have my TechEd EU add-on so that people that sign up for my TechEd plan, they don't get SSL out of the box, but if they purchase my SSL add-on, they're able to then add that to their service bundle. So make sense? And of course you can do this for any of those items that we saw. Yes, sir?
You've shown this. I'm wondering how does this integrate with the definition you already have private clouds and virtual machine management?
So this is specific to websites. The quotas that you create for the VMs service define things like which images are available to your tenants. It defines how many CPU cores, how much memory, how much storage space, what actions they can take, so on and so forth. There's actually a deep dive on the virtual machine service in Windows Azure Pack that's being given by Mark Umeno this week. And so if you're more curious about what the experience looks like then, I would recommend that you attend his session. As I live in the web world, I'm familiar with what our partner teams are doing, but by no means am I a domain expert there. So I would not want to speak on behalf of someone else's feature, okay? Okay, cool. So that's plan and add-ons for you. So this is our final demo of the day. We have 3 minutes left, and I always keep it at the end because it's the riskiest demo we do. It involves talking to Windows Azure, it involves talking to Azure Pack, and it involves us talking to GitHub. And so it breaks sometimes, and I like to have all the good demos happen early so where you guys maybe like the presentation, and then we do the risky demo at the end. Of course, maybe that's not such a good idea because what you'll remember is the demo at the end of the session that broke. So what I'm going to do is, let me show you my demo machine. What I'm going to do is I'm going to go back to my tenant interface, okay? And I am going to create a new website. And we'll just do a quick create, and we'll call this Tech to Cloud. Okay, and while it's provisioning the website there, I'm going to pull up my Azure account. So windows.azure.com. Actually, I need to do this. We have very long and secure passwords at Microsoft. So what I'm going to do over here is I'm also going to create a website called TechEd to Cloud. Website, and I'm going to call it TechEd TechEd to cloud. Okay, I'm going to create that website, and while that website creates, I'm going to go back to my Azure Pack deployment, and I'm going to wait to do this, actually. So what I'm going to do now is I'm going to go to GitHub. Have any of you used GitHub before? So, okay, so hosting service for hosting GitHub repositories. So I'm going to use my personal GitHub account. For this demo, I'm going to sign in, and I'm going to create a new repository. Okay, we'll call this TechEd to cloud. That doesn't sound right. T2C. And I'm going to create the repository. So now that the repository is created, I'm going to go back to my command line. I'm going to go back. I'm going to make a directory. We'll call this T2C. And we will initialize the repository. We will create a new file. And we'll just do, let's see, echo. Fix that syntax error before I have to use that rollback feature again. I'm going to save it. I'm going to add it. And then I'm going to commit. Okay. The next thing I'm going to do is I am going to push this change to my GitHub repository. So the difference here is that this repository isn't hosted in Azure Pack or Windows Azure. It's hosted by a third party. Okay? And so I'm going to push this. It's going to ask me for my username, and it's going to ask me for my password. And so it's now pushing those changes into GitHub itself. Okay? So now I'm going to go back to my Azure Pack deployment. I'm going to set up deployment from source control, and I'm going to say, hey, my repository resides in GitHub. So now what's going to happen is it's going to retrieve from GitHub all of the repositories that exist there. Okay? So I'm going to tell it to use the T2C repository, and I'm going to hit link. And so now it's going to go through the process of linking that project. And as soon as the linking is complete, it's going to fetch those changes, and it's actually going to pull them into my Azure Pack Cloud. Okay? So I'm going to go through and do the exact same thing over in Windows Azure. I'm going to set up deployment from source control, GitHub, next. Tell it to use the same repository, click OK, and it's going to go through the exact same process. Okay? And so what you will see is this application is now running here. Any questions? And it's still going through the deployment process in Azure. It's now done, and I can browse here, and you'll see any questions. So the coup de grace, if you will, is, let's say I wanted to change that again. I'm going to fire up Notepad. We'll edit this. Thank you. And now what I'm going to do is I'm going to add changes. I'm going to, I apologize for the horrible comments, but I'm now going to then push that to GitHub. I'm going to provide it with my username and my password. And so what's going to happen now is it's going to look at those deltas, and at the exact same time, I'm pushing the exact same application with no code changes to both Windows Azure and my Windows Azure Pack deployment. So I'll click Browse. Thank you. I'll click Browse. And no, really, thank you very much. That's all I have for today. So if you wouldn't mind, there's some great sessions that you can check out that cover other parts of this. I'd like to take the opportunity to, chat with you guys about additional questions that you may have as we're out of time. And the other thing I would ask is if you could please evaluate the session today so that I can know what I can improve on to make your TechEd even better next year. So I hope you'll have me back. Thank you very much for your time today. It's been a pleasure.